We know that things can speed up and slow down, but what makes things speed up or slow down? What makes things change direction or change shape? Well, the answer is forces. A force is basically a push or a pull. If I jump off a 10-metre diving platform and accelerate downwards, there has to be a force acting on me. In this case, it's the Earth's gravity. When athletes accelerate at the start of a sprint, the force causing the acceleration comes from their muscles. And when a car comes to a stop, the force causing the deceleration comes from friction. About 300 years ago, the famous English scientist Sir Isaac Newton developed 3 laws of motion, which together can help us explain how forces affect the way that things move. In this video, we're going to look at Newton's first law of motion and at some examples of common forces that affect our lives daily. Newton's first law states that an object will remain at rest or move in a straight line at a constant speed unless acted upon by an unbalanced force. It says basically that nothing's going to speed up or slow down or change direction unless a force acts on it. It's pretty simple really, but it governs the movement of every single thing in the universe. According to Newton's first law, this ball, which is at rest, will continue to remain at rest forever and ever unless a force makes it accelerate. Why should it ever accelerate if some sort of force doesn't act on it? And if something is moving, it's going to keep on moving at the same speed and in the same direction until a force makes it change its speed or direction. Let's look at this collision where I'm standing on a skateboard which is on a trolley that is moving at about 2.5 meters per second. To track the movement, I can place small dots on every second frame of the video on my head, on the front wheel of the skateboard, and in the middle of the trolley. When the trolley hits the mat applies a force on it and it slows down. The dots here are clearly closer together. However, the mat hasn't applied a force on me or on the skateboard, so we keep moving at the same speed that we were moving before the trolley hit the mat. And you can tell because the dots are still evenly spaced. Newton's first law in action. Why should something slow down if a force doesn't act on it? Then the skateboard and my lower legs hit the mat, and the mat applies a force on them, and they too slow down. See how the dots here are closer together, indicating a reduced speed. But the mat hasn't applied a force on my head, so my head once again keeps moving at the same speed as before. Although then it starts falling because it isn't being supported by my body anymore. It finally slows right down when it hits the mat. We often say that we're thrown forward when our car stops suddenly. But are we really thrown forward? In a head-on collision, the barrier in this case applies a huge force on the car, which slows the car down. But that doesn't mean that there's a huge force on the occupants. Apart from a little bit of friction between the occupant's legs and bottom and the seat, there's basically no force acting in the horizontal direction on the occupants. They therefore keep moving forward at the same speed that they were travelling at before the collision, until, that is, a force acts on them as well. In this case, it's the force of the seatbelts and the airbags. I can simulate a car crash on my trolley. Here the trolley slows down when the crash mat applies a stopping force on it, but there's very little sideways force on me, just a little bit of friction. So even after the trolley starts slowing down, I continue moving forward at more or less the same speed as before the collision, until of course a force does act on me. Seatbelts and airbags.
Thanks for watching, dear viewer. This short excerpt from episode 6 of the famous Shedding Light on Motion series, Newton's First Law. In this program, we don't just explain Newton's first law, we demonstrate it in a way that allows all students to fully appreciate this awesome law of nature. Since Newton's laws involve forces, we also investigate and demonstrate a variety of different forces, including friction, air resistance, gravity, lift, thrust, and buoyancy. We finish the program by introducing students to the idea that many forces can act on an object simultaneously, and that they all play a part in how the object moves. You can read a full transcript of the program and download the Outstanding Student Worksheet on our website at www.liakoseducationalmedia.com. So, if you're a teacher and you're looking for an easy but effective way of teaching the topic of motion to your students, visit our website and grab hold of the Shedding Light on Motion series.